So now we are done with conics, and now we're going to solve systems of nonlinear equations. So far, in the beginning of the class, we solved problems that looked kind of like this, and these are what we called linear equations. So we were able to successfully solve problems that look like that using elimination and substitution. And now what we really want to do is solve these equations using those same rules, but the equations are now going to look a little bit differently. So now, let me show you an example. I think it would be best to just start off with an example. Okay, so let's say we had 9x squared plus y squared equals 9, and then y is equal to 3x minus 3. So here, we have a linear system and a nonlinear system. So we have this first part is nonlinear. And we can actually see that this is actually an ellipse, because if we divide by 9, we actually have an ellipse here. Whereas here, we just have a line. So basically, what we're looking for, we have some ellipse, and then we also have a line. Okay? So if you think about it, you might end up with two different solutions because a line will intersect an ellipse at two different points. And that's basically what the nonlinear part is saying. So now, here, same rules apply. You can use substitution or you can use elimination. Now, in this case, elimination might be the worst because you basically want to have the same variables. Notice here that you have x squared and y squared. This one only has an x and a y. So substitution actually would be better here. So what I'm going to do is that I'm going to substitute this 3x minus 3, because y equals that, into the other y. So what we have is the following. We have 9x squared plus parentheses squared equals 9. And what exactly am I plugging into that parentheses? What I'm plugging in is that 3x minus 3. So what is this going to give me? This is going to give me 9x squared. This means that I have two of them, so I have to FOIL this out. This is 3x minus 3, 3x minus 3. And then the other part is just going to be equals 9. Okay, so I'm going to have 9x squared plus, this is going to give me 9x squared minus 9x minus 9x plus 9 equals 9. So this part is going to be 18x squared. This part is going to be another minus 18x. Plus 9 equals 9. Okay, notice that I can subtract the 9 over and they're going to just go away. So I'm left with 18x squared minus 18x equals 0. Now how do you solve this? Well, let's factor out an 18x. So you're going to just have an x minus 1 equals 0. I'm going to set both of them equal to 0. So you're going to have 18x equals 0 and x minus 1 equals 0. So x equals 0, that's one solution, and x equals 1, that's another solution. So notice, as we predicted, because it was in a line and an ellipse, you actually have two different solutions. Now, is this the answer? No, because we only found our x value. Now we got to figure out what our y value is. So when x is equal to 0, which one would be the easiest to plug in? Well, the second one will be the easiest because y is already solved for. So y equals 3x minus 3. Plug in the 0, 3 times 0 minus 3. This goes away, and I'm left with a minus 3. So the first solution is 0, negative 3. That is my first solution. My second solution, I'm going to plug in x equals 1. So y equals 3x minus 3. So I'm going to have y equals 3 times 1 minus 3. Y equals 0. So my other solution is 1, 0. Okay, so those are my two solutions. Okay. Alright, so just the same methods as before, just a little bit different. Now, let's say you wanted to use elimination. Like, substitution is good. Substitution usually is good when you have different types of variables that are not the same. Now, if you have things that are, if you really like elimination, you can use elimination, but you have to be careful with when you use elimination. So for example, problems that look like this. X squared plus y squared equals 7. x squared minus y squared equals 1. Something that looks like this would be a perfect example of when you can use elimination. Because if you notice, you have an x squared and an x squared, and a y squared and a y squared. And luckily for us, this can immediately eliminate. So I can just add them all up. This is going to give me 2x squared. This is just going to go away. Whoops. Oh no. This is going to go away. It's going to be equal to 8. I'm going to divide by 2 to both sides. So x squared is going to be equal to 4. Then I take the square root, but when I apply the square root, I also add plus or minus. So x is equal to plus or minus 2. So now I have two solutions. So I have x equals 2 as one of the solutions, and x equals negative 2 as the other solution. Okay, how do I know which one's the solution? Well, I can plug it into whichever I want. Well, I'm going to plug it into the first one. Okay, so I have x squared plus y squared equals 7. Plug in the 2 in there. I'm going to have 2 squared plus y squared equals 7. So I'm left with 4 plus y squared equals 7. So y squared, I'm going to move the 4 over by minusing the 4, and I'm going to get a 3. Take the square root to both sides and add plus or minus. Y equals plus or minus square root of 3. Okay, so when x was equal to 2, this ended up having two solutions. Now let's plug in x equals negative 2. So x squared plus y squared equals 7. I got negative 2 squared plus y squared equals 7. So you got 4 plus y squared equals 7. Y squared equals 3. Take the square root to both sides. I'm going to get y equals plus or minus square root of 3. Okay, so what are going to be my solutions? Now, one of the things that you do have to check all solutions that they all match up. So let's look at the first one. So this is going to be, so when x equals 2, you got two solutions. You got one with a square root of 3, and you got another one with a negative square root of 3. Okay, and then when x was equal to negative 2, you got one that was with a positive square root of 3, and one with a negative square root of 3. So here you ended up getting 4 different solutions. And one of the things that you really want to make sure is that you really check your work. Make sure that they all satisfy these answers. And notice, why did we get 4 solutions? Well, think about it. This thing is just what? That's just a circle. Okay? And here we have a hyperbola. Okay? So if you think about it, here's a circle. A hyperbola probably looks something that looks like this. And where they intersect, you actually get 4 different solutions. Okay? Doesn't mean that you're always going to get 4 solutions, but it is probable. Okay? So let's just do one more example. So let's say we want to solve the systems of nonlinear equations. X squared plus y squared equals 9, and x squared minus y equals 9. So notice that we have a circle on the top, and then we have a parabola on the bottom. Okay, so which one do you want to use? You can easily use elimination if you want. However, if you do use elimination, notice that the y squares are not going to eliminate. You're going to have a y squared, and you're also going to have a y. So I think in this case, the best thing to do is use substitution. Now, what I would suggest is don't solve for the x, because then you're going to have a plus or a minus. What I would suggest is solve the thing that doesn't have a squared, which is the y. So I'm going to use this equation number 2. X squared minus y equals 9. I'm going to solve for the y. So minus the x squared first. So negative y equals 9 minus x squared. Divide by the negative 1. So you get y equals negative 9 plus x squared. Okay? And now what I'm going to do is I'm going to plug this thing into the first equation. So I have x squared plus y in this case was negative 9 plus x squared, whole quantity squared equals 9. Okay, so I'm going to have x squared plus negative 9 plus x squared. I have 2 of these, which I'm going to have to FOIL out, equals 9. Okay, so x squared, FOIL this out, it's going to be positive 81. This time this is going to be negative 9x squared. Here and here, another negative 9x squared. And the last one, positive x to the fourth equals 9. Okay, so now I have an x to the fourth. I'm going to write that first. I have an x squared here, an x squared here, and an x squared here. And what this is going to give me is negative 17x squared. And then positive 81 is equal to 9. Okay, I'm going to minus the 9 over here. And you'll see why. I'm going to get x to the fourth minus 17x squared. And then I'm going to take this 81 and subtract it to 9. And what I'm going to get is 72 equals 0. Now here, what does this kind of look like? Well, this looks a lot like the u substitution. So you can actually either factor it in immediately if you want to, or you can use a u substitution. Let u equal x squared and u squared equal x to the fourth power. Okay, because this is double what that is. So this is going to be u squared minus 17u plus 72 equals 0. Okay, by just using the u substitution. And now let me factor this out. So this is going to be u and u. Two numbers that multiply to get 72 and add up to get negative 17. This is going to be 8 and 9. And they're both going to be negative. So I'm going to get u minus 8 equals 0. U minus 9 equals 0. So u equals 8. And u equals 9. Now remember, u initially was x squared. Okay, so x squared equals 8. And x squared equals 9. So x here is going to be equal to plus or minus the square root of 8, which is 2 square root of 2. And this is going to be plus or minus 3. Okay, so there was a lot of things that we needed to remember from the previous section as well. Okay, now that we know what our x's is, now let's figure out what the y is. Now the best one to use is use this one, since we already know what y is there. So first I'm going to start off with x equals 2 square root of 2, the positive one. So let's figure out what y is. Y equals negative 9 plus 2 square root of 2 squared is going to be negative 9 plus 8 is going to give me negative 1. So my first point is 2 square root of 2, whoops, that's wrong. 2 square root of 2, comma negative 1. That is my first answer. Alright, now I did that, the positive one, now let's do the negative one. X equals negative 2 square root of 2. What is going to be the y value? Y equals negative 9 plus negative 2 square root of 2 squared. So this is just going to give me y equals negative 9 plus still another 8, which still gives me negative 1. So my next problem, or my next answer is going to be negative 2 square root of 2, comma negative 1. That is my second solution. Now let's plug in the positive 3. So I'm going to get y equals negative 9 plus 3 squared. Negative 9 plus 9. That's just going to give me 0. So this answer is going to be 3, 0. And then finally, x equals negative 3. So y equals negative 9 plus negative 3 squared. That's going to give me negative 9 plus 9, which also gives me a 0. So the answer is negative 3, comma 0. Okay, so here are my 4 solutions, and you can check them and see that they're right. So this one, this one, this one, and this one. So yes, you do have to know a lot of the things from the previous chapter. So if you still feel really iffy about the u substitution, go ahead and watch the video again, just because it is going to be a little bit crucial to know that. Now, you could have immediately just factor this if you wanted to, just without using the u substitution, just letting x squared minus 8 and then x squared minus 9, and just going directly from here without using the u substitution. But if you need to use the u substitution, just go ahead and do it.